Okay, so now we'll look at using base 10 blocks for subtraction. We can start out with something as simple as 8 minus 4. And we do that, well, first thing we'll do is we represent our minuend, in this case 8. Now, we're not going to represent our subtrahend here because this is not something I'm adding to it, it's something I'm actually taking away. So 8 minus 4, I'm just going to take away 1, 2, 3, 4. 8 minus 4 is 4. And then, of course, you could do that pictorially by drawing your 8 and then mark off 1, 2, 3, 4, so you're left with 4. Then as we move up into our 2-digit and 3-digit and so forth, so if I have 53 minus 27, again we start by representing our 53, which is our minuend. So 10, 20, 30, 40, 50, 3. We do not have to represent our 27 because we're taking it away from the 53, not adding it to. Get all the rest of these out of the way. Okay, so what I'm going to set it up over here on the side, 53 minus 27, in standard algorithm so that I can show them simultaneously here. So here's our 53. Now, we're going to start in our ones column, and right now in our ones column we have 3. We need to take away 7. Well, obviously you can't take away 7 when there's not 7 there. So this is when we have to do our regroup. And just like earlier, in addition, when we got 10 of these, we brought it over here. We're going to do vice versa here. We're going to take one of these, and we're going to make that exchange. So this rod is worth 10 ones. So I'm going to now take, okay, this rod is the same as 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I take this out of the tens column and I put these into the ones column. So as I do that up here, a standard algorithm, we came over here and we said, I need to get one of your tens. And when we do that, I'm left with 4 tens here. And the 10 that I now borrowed comes to the ones place and gets regrouped as 10 ones. So I always want my kids to write that instead of just writing a 1 up there. And then what did we add to the ones place? The answer is not 1. We added 10 to the ones place because we regrouped from over here. So now we have 13 ones, and we're going to take away 7. 1, 2, 3, 4, 5, 6, 7 has been taken away, and we're left with 6. 13 minus 7 is 6. Now, from our tens column, we have 4 minus 2, so we'll take away 2 tens. 10, 20, 26. So that's how you would represent regrouping or borrowing in base 10 blocks. We could then go on up and do the same thing with a 3-digit number. So let's say we have 123 minus 56. So 123. There's your minuend. And you need to take away 56. So we do the same thing and say, okay, let's start over here in our ones place. And I only have 3, and I need to take away 6. So I'm going to come regroup one of these. For 10 of those. Okay, so one of these exchanges. And you can always prove it to the kids by lining them up for 10 of these. Okay? So we'll make that exchange. When you do that standard algorithm, you say, I took away one 10 and I turned it into 10 ones plus the 3 ones that were already there gives me 13 ones. Now I can subtract my 6. So 3, 4, 5, 6 leaves 7. Okay? Now we come to our tens column, and right now in my tens column, I have this 110, just this 110, and I'm supposed to take away 5 tens. I can't take away 5 tens, so I'm going to say, all right, this thing right here, which is a 100, is the same thing as 5, 6, 7, 8, 9, 10, as 10 of those. So we can, once again, we can say we're going to exchange this 100 for these 10 tens. I'll lay them here. So showing that on standard algorithm, we go, I'm going to take away this 100, and I'm going to change it into 10 tens, plus the 110 I already had is now 11 tens. So I'm going to take away 5 tens, so 1, 2, 3, 4, 5, which leaves me with 6 tens, and my difference is 67.